Hello, everybody. Welcome to today's webinar regarding Xanbus sizing. Thanks for joining. My name is Giannicola Biancofiore. I am a field service engineer in Schneider Electric. Please bear in mind that this presentation is not replacing installation and operating manuals. Remember that equipments will need to be serviced and installed by qualified personnel. And please always consult our documentation before maintenance or servicing and installation of the equipment. Today's agenda, we will discuss about Xanbus sizing. Today's agenda is especially focused on the explanation of what is Xanbus. Then we will explore the cabling and network topologies, the power supplies, the network architectures and their limitations, and some hints and troubleshootings. At the end of the webinar, we will have a session of question and answers. So you will be able to type your questions and I will try to answer to all of you. The source material for this presentation is documentation you can find in our Solar website, which are installation and operation manuals and also special application notes. So let's get started discussing about this Xanbus. What is Xanbus? Xanbus is used in networks architectures involving our Connext products. In this presentation, we will especially consider inverters, chargers, XW Plus, and COMBOX, and other accessories like SCP, AGS. But in the future, we will have another webinar which will involve also newer products like the XW Pro or the Connext Gateway. So today we will discuss especially what are the best ways to fit Connext devices in a network or in master-slave networks. And our goal is especially to define constraints under which the networks are can guarantee a proper functioning of the devices. So we will see what Xanbus network does, interconnection of devices, delivering or transporting the power supply also to the devices, and allowing to create a reliable network for the communication of the devices. What is a Xanbus network? It is a CAN-based peer-to-peer communication protocol used to cooperate, to allow cooperation of the devices into the network. And this is achieved by using data packets called PGNs. Basically, in a Xanbus network, the participants broadcast their data into the network, to all the network. And there are devices like the COMBOX that are able to gather the data from every device and populate also a cloud if available. And Xanbus network consists of course, Xanbus-enabled devices, power supplies, cables, and network terminators. Each device is integrated into the network using a cabling that we will explore further on. So an Xanbus-enabled device is a product that works and that it's compatible in Xanbus network. The advantages of the Xanbus network are the facility of the usage, because the network simplifies certain operations and configuration, for example, or other kind of tasks. Reliability, because the software helps to reduce errors due to the analog signaling. The accuracy, because digital information is less susceptible to interference and line losses. And also the feature of upgrading the firmware of all the devices. We always encourage to upgrade firmwares, because new firmwares, of course, improve stability, can contain improvements to features, and can protect you also from network vulnerabilities, for to protect from cyber threats that may occur. So we always encourage you to upgrade the firmware whenever a new version is available. The flexibility of a peer-to-peer communication scheme that doesn't require the master controller to function as well. So today we will explore especially the XW Plus inverter charger, the charge controllers MPPT 60 or 80, the COMBOX, and other accessories like the battery monitor, the automatic generator start, and the system control panel. Let's explore the cabling of Xanbus network. The configuration of the Xanbus network is made up of a so-called daisy chain. A daisy chain means that each device is connected to the following one. The total length of the network is 40 meters or 130 feet. Of course, being a daisy chain, we can't remove a device without replacing it or without restoring the network, because if we don't do it, of course, the network will be interrupted. So replacement of whatever we have removed, or reconstruct the cabling in order to obtain again the same configuration of a daisy chain without any interruption. So one device attached to the other. The Xanbus network needs termination. This means that the first and the last device of the network needs to have a terminator of which is a resistor of 120 ohms. We always include the terminators into our products, so you can always create a daisy chain configuration using the included resistors. We don't allow, or in other words, it's not recommendable a configuration without terminators. So this picture reproduces in a more realistic situation what will be like the network configuration. For example, at the left, we have an MPPT charger. We have immediately after an XW Plus charger, inverter charger, an AGS, an SCP, and as you can see, first device at the left and last at the right does have a network terminator. What is how can we create the cabling of the Xanbus network? The cabling is obtained by category 5 or 5E or above category cables. As you probably know, these are twisted pairs cables made up of 4 pairs. And we can have 2 possible standards, T568A or T568B. What each of the 8 pins is transporting. As you can see in the table at the right, pins number 1, 2, and 7 are transporting a net S, which is the power supply over the network, typically 15 volts. Then we have pin 3, pin 6, and pin 8 carrying the negative. And then CAN L and CAN H, pins 4 and 5, are transporting what is essential to the communication, the bus of the data. In which differ the two standards available for creating a Xanbus network with the T568 and 568 A and B cables. Basically, they are two color codes using that can be used in one or the other, but we cannot mix the configurations. We cannot mix one set of cables with another. So if we choose to use T568A, we cannot use at the same time in other connections T568B. So we always have to use one standard. And as you can see, the color code is not the same for the two standards. Also, we need to use straight-through cables, and we cannot use crossover cables because pin 1 is crossed with pin 3 and pin 2 is crossed with pin 6. So we could create problems between data and power supply. It's recommendable to use machinery molded cables, like, for example, the one here on the right picture, because manually crimped cables, like the one on the left here in the picture, could result in bad crimping. Unless you don't have a cable tester, it's recommendable to use machinery molded cable with a minimum length of 2 meters to ensure reliable communications. Don't confuse Xanbus with Ethernet. Despite the cables are the same, they are totally different, and they are not the same kind of networks. So Xanbus is not an Ethernet system. You can connect Xanbus-enabled devices only to other Xanbus-enabled devices. Do not attempt to connect Xanbus-enabled devices to other networks. And don't install network terminators in AC sync ports, which is typically a port that you can find in the XW plus inverter. What else regarding the cables? Some recommendations for a correct installation. Do not route the Xanbus cables in the same conduit or panel as are the AC and DC power cable. Xanbus cables in contact with DC or AC power can transmit an electrical shock. Route the cables away from sharp edges that might damage the insulation. Avoid sharp bends in the cable, no less than 100 millimeters radius. Allow at least 2¼ inches or 57 millimeters of space behind the wall to accommodate the depth of the unit, and allow room for the cables to bend. Allow some slack in the cable tension. Tensions shouldn't excess 25 leads or manufacturer recommendation. Keep the alignments or white pairs inside the sheet as straight as possible. Keep data and power cables separate. Data cables should only cross over a power cable at right angles. Avoid using metal cable staples. Use appropriate hardware fasteners to avoid damage to the cable. Support horizontal cables using J-hooks or cable trays. Power supply. So, as we saw before, the Xanbus network is transporting not only a data bus, which is two of the cables inside the RJ45, let's say, cable, but we are also transporting power. So bear in mind that Xanbus devices can be either power supply or power consuming. The network needs at least one device with the capability of supplying power sufficient to power all the accessories in the network. So in other words, we need the balance of the devices capable of generating the power, not really a balance. We need more power from the devices capable of generating power with respect to the devices consuming power. So the total network current supplied by power sourcing devices must be equal or greater than the total current drawn by the power consuming devices. The power supply must be capable of providing typically 15 volt DC at 200 milliamps to each device. I have here a table explaining better each device and its power capability or power consumption details. For example, the XW Plus inverter charger can supply 800 milliamps at 15 volts. So, for example, if we consider the COMBOX, which is consuming 200 milliamps, one AGS, which is also consuming 200 milliamps, one SCP, and one battery monitor that also consume 200 milliamps, an XW Plus could supply these four devices because 800 milliamps is the sum of four devices consuming 200 milliamps. Also, we have the MPPT80, which can provide 400 milliamps. The MPPT60 cannot provide power supply over the network. And the Connex SW can provide around 500 milliamps at 12 volts. In a system with an XW Plus inverter charger, like I said before, SCP and AGS, the inverter charger can give 800 milliamps, and the other device can consume a maximum of 200 milliamps for a total consumption of 400 milliamps. So this is another example. In this case, the network is properly configured from a power perspective because the power source is capable of providing more current than is needed. The MPPT60 is a special case because it is a device is not consuming nor providing power on the Xanbus network. So it has only, it takes its power from the batteries, so from the solar power. Anyway, in a scenario where we have, for example, a COMBOX and an MPPT60, we can use a configurable auxiliary port that is embedded into the MPPT60, producing 5 to 13 volts and up to 200 milliamps that can be turned on and can be used to power the Xanbus network. So we can use this auxiliary port like detailed in these two more slides. Here, first of all, we have to enable the auxiliary port going in the auxiliary menu. Set aux control mode to manual on, set the output level to 13 volts, and checking if the output is active high. So at this point, the MPPT60 is providing power on its auxiliary port, and we can take advantage of this port to power on the Xanbus network. This is a principal diagram. So the auxiliary port is represented on top, and we can join the positive and negative to the pins we called before net S and net C, and we can reconnect straight to the bus the Xanbus pair transporting the data. Bear in mind that as we are relying in this example of power supplying the network only on the batteries, so on the solar power, if we have suspected that this source could become insufficient, we should provide an external connected to the AC network power supply if we want to perform, for example, firmware upgrades. If, as said, if we suspect that the primary source of energy can become insufficient. So what are the networks, architectures, and limitations? I want to remind you that at the end of the presentation, we will have a section of Q&A, so you can type your questions at the end of the presentation. I will try to answer to your questions. Okay, what are the limitations of the network? Of course, we have limitations. Because, like we said before, the participants to the network send packets to the network, and this implies a bandwidth usage. So the number of and the class of the devices affect the bandwidth of the network. Devices such as the XW inverter charger consume more bandwidth than, for example, charge controllers, other accessories like SCP, AGS, or other RS485 devices. So recommended limitations are up to 9 XW plus inverter chargers for single Xanbus network, up to 20 Xanbus devices for general Xanbus devices for single Xanbus network, up to 32 RS485 devices, which can be, for example, PV inverters or meters and weather station or accessories like that. More, in a single Xanbus network, one COM-box can monitor both Xanbus devices and the Modbus device, RS485 devices. In a system with the two Xanbus networks, typically we need 3 COM-boxes because one is acting like master for aggregation of data and providing a unified view of the system to the end user. Then we have the slave COM-boxes reporting to the master. So let's explore some network configurations that will function properly because they are properly sized. In this example, for example, we have a small DC coupled system. As you probably know, a DC coupled system is when we couple the PV power coming from solar panel that are connected to a charge controller and then to the batteries. And then we are coupling the PV power using the DC array of the XW plus inverter charge. So in this network, we have a Xanbus branch on the right where we have connected 3 XW plus, 8 MPPT, which can be 60 or 80, 1 battery monitor, 1 SCP, 1 AGS. So we have in total 11, 12, 13, 14 devices, which is less than 20 devices. So it's okay. And on the left, we have a Modbus branch, including devices like a power meter or devices like that, only 2 of them. So we are in the range of the allowed limitations. Another DC-coupled system could be the one represented here. In this one is a larger one, so as you see, we have two COM boxes acting like slaves and one master COM box. The master COM box and the slave COM boxes are connected to a router. In this case, the master COM box is managing the Modbus devices, the power meters, and nothing else. Instead, the two COM box slaves are managing the first one, the charge controllers, 12 of them, one AGS, one SCP. The COM box slave number 2 is managing 9 XW plus inverters, 3 battery monitors, 1 AGS and 1 SCP. Also, in this case, we are respecting the sizing limitations. This is another kind of network called the AC-coupled system. AC-coupled system is when we are coupling the PV power using to the AC rail of the XW plus, for example, coupling the PV power using PV inverters. So this is typically called AC-coupled system. This COM box in this architecture is managing at the same time Modbus devices, which are in this case 6 PV inverters, 1 power meter, and on the right we have the Xanbus network, which is including 6 XW plus, 1 battery monitor, 1 AGS, and 1 SCP. More networks, we have a larger AC-coupled system here with 3 COM boxes, two slave COM boxes and 1 master. The slave COM boxes on the left is managing the Modbus devices. Then this COM box is connected to a router, and the same router is also connected a slave COM box, including 9 XW plus inverters, 1 SCP, 1 AGS, and 3 battery monitors. Also, it is possible to create large mixed AC-DC coupled systems. This means that the PV power is connected, coupled, in other words, at the same time on the DC rail and also on the AC rail of the XW plus inverters. So this is an example of it with a master COM box managing Modbus devices and at the same time managing Xanbus devices, and then a slave COM box in which we have separated the MPPT's charge controllers. Of course, when we are configuring a system, including master and slave COM boxes, we need to define the role of the COM box, which can be a master or a slave. For example, in this slide, in this picture, you can see how to configure the COM box as a master of a cluster, for example. And here in this other slide, we are configuring a COM box on a slave. There are better details, more details of this in our installation and operation manuals. Some troubleshooting points that may be helpful when designing a Xanbus network. As we said, Xanbus can deliver power to Xanbus accessories, like the COM box, for example. So it may happen at the first setup using Xanbus power source is not recommendable because the COM box clock could override the other Xanbus devices' clocks and could trigger unintentional time-based events. Therefore, do not connect the COM box to the Xanbus network prior to setting up the internal clock of the Connex COM box. refer to changing the time in the COM-box owner's guide, and if Xanbus is the only source powering the COM-box, after installation, verify the time settings for all the devices. The COM-box compatibility list is XW Plus inverter charger, the AGS automatic generator start, the SCP system control panel, the SW inverter charger, the MPPTs 60 or 80, the battery monitor. Remember that the COM-box supports up to 20 devices on a general Xanbus devices on a single Xanbus network, and a maximum of 9 XW plus, because their bandwidth usage, as we said before, is higher. Compatibility between different firmware versions in a master-slave system is not guaranteed. Therefore, ensure the same firmware version is installed on all the COM-boxes in a master-slave system. When there are more than 6 Connex SWs or 10 Connex MPPT devices, it's not recommended to use the COM-box or SSP with the option of cascading the settings to configure settings on the attached Xanbus devices. Adjusting device settings from the COM-box on such large systems can be unpredictable. Use the Connex configuration tool to do that with supply software to configure device settings on such large systems. When using a Modbus master tool or a device to communicate with the master-slave COM-box system, a Modbus connection is required to each COM-box to control and read status from the devices attached to that COM-box. Modbus commands are not cascaded between COM-boxes. When performing a firmware upgrade of Xanbus devices in master-slave system or in any system with a large number of devices, it's recommended to power on only the Xanbus devices being upgraded and leave all other Xanbus devices powered off to improve the speed and reliability of the upgrade. What if devices wired to the Xanbus network do not show up in the system control panel? Generally, this is due to miswiring. So could be due to missing network terminations. What if multiple MPPT60 charge controllers where apparently wiring and terminators are correct, but one or more of them are not displayed on the SCP? It might be helpful to restore the MPPT60 to the default to correct the issue. Some Xanbus configurations, if the system has 3 or more charge controllers, it may be necessary to remove one network terminator in order to boost the signal strength on the Xanbus network. In this case, changing the order of the devices so that the SCP is located centrally in the devices chain can work in some cases. So.